In this video, we're going to have a look at exponential modeling. So there's going to be a little bit of differentiation involved and also solving exponential equations. So first of all, it's giving you an equation for temperature capital T in terms of little t, which is time in minutes. It's asked you to find the rate of change of temperature in terms of K. So the rate of change of anything is just asking you to differentiate that variable. So here we want to differentiate the temperature with respect to time, d little t. Now, when doing this, we use the fact that, well, if y is in the form e to the kx, then we can say that dy dx is in the form of ke to the kx. Using that idea, that means that e to the minus kt, in this instance, sorry if you can't read that, would differentiate into minus k e to the minus kt. So basically, you differentiate, actually even an easier way to think about it is you just take this and you multiply it to the coefficient. I don't want to complicate things. That means that 75 e to the minus kt would differentiate to minus 75k e to the minus kt. So that's what our dt by dt would be, minus 75k e to the minus kt. And we also differentiate that second variable 22, but that just differentiates to 0. So we don't need to, you can add 0, but then yes, there's no point. That's part A done. Let's now move on to part B. It says after 5 minutes, the temperature is 70 degrees. So because little t is time in minutes, we can say when t is equal to 5, capital T is equal to 70. Putting that into this equation, we get that 70 equals 75 e to the power of minus kt. Kt is k multiplied by 5, so that's minus 5k plus 22. We then rearrange to make k the subject. You start by subtracting 22 from both sides. So you get that 48 equals 75 e to the minus 5k. Divide both sides by 75, which gets you 48 over 75 equals e to the minus 5k. From there, to get k in a solvable format, we need to bring it down as a coefficient. In order to do that, we have to apply logs to both sides so that we can bring it down. In this case, we're going to choose a log that with a base that matches this variable here, e. That's log base e, or otherwise known as ln. Let's apply ln to both sides. Ln 48 over 75 equals ln e to the minus 5k. Now that we've involved logarithms, we can bring the power forward as a coefficient, so it becomes minus 5k ln e. And what do we know about ln e? Well, it's just equal to 1. So we can just say that altogether minus 5k is equal to all of this. Divide both sides by minus 5 and we get k is equal to minus ln 48 over 75 all over 5. I took into account the minus here and the division by 5 here. Putting all of that into your calculator, you'll get a value of 0.0893. And that's your final answer to this question, to 3 significant figures. Let's now have a look at part C. And I'm just going to change the color of the pen because it's getting a little bit monotone. What we want to find is how many minutes, the value of t, when the temperature capital T cools to 55. In order to do that, we're going to replace capital T with 55, and we're also going to use the value of k that we just found as our constant, because that is a constant throughout the whole equation. So we have capital T temperature equals 75 e to the power of minus k, which is 0.0893 t, all of that plus 22. Start by subtracting 22 from both sides, so 33 equals 75 e to the minus 0.0893 t. Divide both sides by 75. Just to simplify things, I'm going to write out like this. Once again, we need to bring t forward as a coefficient, so you apply logs to both sides, and we choose the base again to match this variable here. Log base e, which is ln, again. ln 33 over 75 is equal to ln of everything on the right hand side, which looks like this. Once it's in this format, you can bring this forward as a coefficient, and you can say ln of 33 over 75 equals minus 0.0893 t ln e. Again, because ln e is just equal to 1, you can just cancel that out, because if you're multiplying by 1, it's just this variable itself. From here, you divide both sides by minus 0.0893 to get the value of t, minus, so I'm taking quite a few shortcuts by cancelling out, It's because there's no point writing it out again. All of that's equal to t. That's the 75, by the way, sorry about that. And we get that t is therefore equal to 9.19. If it takes exactly 9.19 minutes for it to cool to 55 degrees, it wants the number as a whole number. So after 9 minutes, it hasn't cooled to 55 degrees yet, whereas after 10 minutes, it's cooled past 55 degrees. So we can say this is our final answer. Hopefully that all made sense. If you have any questions with it, just let me know. Otherwise, thanks for watching, and be sure to subscribe. I'll post more content like this every single day, and like the video if it helped.